Yes.
Wonderful. My name is Cameron. I'll be one of your AV techs for today.
Perfect.
For the projector and for the podium. Just making sure everything is all connected and working for you. If you have any problems, my business card is right over there just to make sure it's all working.
Perfect.
And you have already set your computer to do not disturb, everything like that.
Yep.
Are you comfortable with the mic level?
Yes. Yeah.
Because we want to make sure it's working for you, so if you feel like it needs to be closer, you can adjust it like so, and we can adjust the volume level as well.
Perfect. Thank you.
All right, folks, we're going to go ahead and get started with the last talk in the Celebrating the Sci and SciPy session. This is from Sarah Purpura.
Yeah.
From Legacy to Leading Edge, Revamping NCEI Software, which I hope she'll explain, from the cloud era, for the cloud era.
Yeah, thank you for that introduction. My name is Sarah Purpura. I am a NOAA contractor with Riverside and CSS. And I'm a software engineer and product manager and kind of scientist on the side too. I have a background in meteorology and have kind of transitioned into software engineering. So today I'll be talking about how we are revamping NCEI software for the cloud era and how we are using scientific Python to do that. So what I'll be going over today is our scientific problem that we're trying to address, and then some DevOps that we are trying to incorporate into our pipelines, and then some of the projects that we're working with scientific Python, and then diving deeper into a few of those projects, and then how we're using open tools to bridge the science and industry, and then any questions afterwards. All right, so what are we doing? So we are trying to connect industry with actionable data, products, and services to help build a more resilient or climate resilient nation. And this effort is developed with 3 different industry partners, so insurance, reinsurance, retail, and architecture and engineering. And this is through NOAA and through NCEI. And we are trying to help to empower rapid decision-making as well as improving that information for those sectors. So as I mentioned, we're working with these 3 different sectors, and we are trying to help to have more or better decision-making with updating outdated code bases, as well as removing manual interventions for delivery pipelines. We're also looking to create more maps and products that these sectors can use to do that. So some goals of what we're doing with the refactoring and modernization is to have functional enhancements, so improving the features and capabilities of the software. We're also looking to consolidate and streamline our data, so making sure the processes and procedures are more streamlined. We're also looking to update technology, so incorporating modern technology like CI/CD and going from Fortran to Python. We're also looking to simplify the code base, so making sure the code is more efficient and easier to maintain in the future. And then we're looking to redesign operational techniques, so making sure the workflows and methodologies are all updated, and then getting ready for the cloud. So making sure that the software that we're building is prepared for any cloud environment, even off the cloud, just making sure that it's ready to go whenever we do move to a cloud. So some DevOps that we are trying to incorporate into our pipelines. We are working in GitLab specifically for our version control to help with our traceability and audible transformations, which I know everyone here supports. We're also using pip and conda to help to install and upgrade and manage our Python libraries that we're working with for our dependencies. We're also using containers, but we're working with Podman to do that to ensure long-term consistency, and then it's able to help us get to the cloud as well. And then we're also automating our testing for each pipeline through CI/CD. So what does cloud ready mean for us? The big one is having CI/CD in GitLab. We've kind of spearheaded the CI/CD movement, I guess, in NCEI. We're trying to show the breadth of why this is so important to help automate builds, tests, and deployments, not just have it in scientific code. We're also working to containerize our applications, as I mentioned earlier, with Podman, and this will hopefully help us to deploy to whatever cloud environment we have. And then we're also working with the NOAA Open Data Dissemination, or the NOD, to output our data publicly through 3 different cloud commercials, through Google Cloud, AWS, and Azure. So that is our goal, to have all of our data up into the cloud. All right, so how are we using scientific Python in this context? So I'm going to walk through some modernization products that we are working on. So modernization in this context means we already have products in a prod environment. It's already in production, but now we're coming in and trying to update it, make it more modern, and helping it to run quicker. So the first one, if you attended Brody's talk, he talked about GSOM GSOI, which is the global summary of the month, and global summary of the year, which creates monthly and yearly summaries from station-based climate data for the GHCN daily, and that was in Java, and he is now putting it into Python. The next one is ASOS, which is our near constant stream of data across 900 ASOS sites, and it's being completely rewritten according to modern coding standards that Tad up here is working on as well. It was in Fortran, and we're now putting it into Python. The next one is IBTracks, which is the International Best Track Archive for Climate Stewardship, and this provides near real-time updates on tracks and strength of active storms and analysis. And this was in IDL and Bash scripts, so again, we're porting that to Python. And lastly is DatZilla, which allows users to submit requests for data point investigation for the GHCN datasets, and this is building a UI to support that. So these are all the libraries that we're using for these different products. As you can see, we're exclusively using either polars or pandas for all of these projects. That has been really helpful for us to rapidly prototype into what we are building, because there's so much data that we're ingesting and trying to clean up. We're also using NumPy as well as Numba. And then we're using Flask for our UI and PsychoPG for our database. So now I'll talk about the new products. So these new products are coming directly from the users that we're working with in those 3 sectors. So these are not in production, and they're brand new. So any feedback on libraries that you think we could use for these, I would greatly appreciate it. But the first one is TMY, and this provides a historical or future typical meteorological year using meteorological and solar radiation data. The next one is Event Footprint Catalog, and this will create an easy-to-use shapefile or GIS formats of past weather events characterized by their physical impact footprint using both observational and remote sensing data. The next one is billion-dollar disasters. This product captures large-scale disasters tracing back to the 1980s and provides risk metrics based on disaster exposure over time by aggregating data from FEMA, USDA, NOAA, and other private sector sources. And then there is Storm Event Database, which Ted has also worked on, which enhances our user access to NWS storm data and will allow users to generate PDFs of their search results in download or certification. And then lastly, we have the automation technology optimized for monitoring artificial intelligence, which is a mouthful, so we just call it NCEI. We have one direction going in the AI route and another direction not using AI in case there are restrictions with AI. But the overall goal of this is to use this to help automate the process of gathering information for the monthly NCEI reports and limit manual overhead. So here are the spread of the scientific Python libraries that we're using to accomplish these scientific goals. And again, we're either using polars or pandas across every single product. We're also using NumPy in almost all of these. A fun one that we've been kind of playing around with is Beautiful Soup in a few of these projects to web scrape a bunch of information from either the National Weather Service offices or from international pages to get more information. We're also using, again, Flask for the UI for the NOAA portion, and then PsychoPG to pull out everything from the databases that we need. And we're also using NetCDF. There's a few data sets that have NetCDF files that we need to pull in and manipulate as needed. And then geospatially, we're using GeoPandas in a few of our projects, CartoPy and Matplotlib to visualize everything that we're creating. So this is just a picture of all of those products that I had just mentioned. Again, that spread looks very similar. We're using NumPy in almost everything. We're using pandas and or polars in almost everything. We're using a lot of geospatial data to visualize with Matplotlib and CartoPy. And then the PsychoPG one should be a little bit higher. We keep adding more and more projects that require databases, so we're using that as well. All right, so now I wanted to dive into a code modernization example a little bit deeper and how we're going about this. So I wanted to talk about IBTrax. So again, IBTrax is the International Best Track Archive for Climate Stewardship. And this is the most complete global collection of tropical cyclones available, and it merges recent and historical tropical cyclone data from participating national and international meteorological agencies. So the purpose of this is to aggregate vital storm information from over a dozen different global agencies. It provides a near real-time update on the tracks and strength of active storms for analysis, and it produces multiple versions of tropical cyclone data for accessibility. So this product already exists, but as I mentioned, it's all in IDL and Bash scripts. So with the modernization goal, we're focusing on porting this to Python for more efficiency and ease of future upkeep, since a lot of scientists know Python, and that's who we will be handing it off to. All right, so how are we going to do this? So that just a high level of a walkthrough of what we're trying to do. So we have a manual QC process that will go into 22 different agencies. And this manual QC, I believe, happens before it gets to us. So we have 22 agencies. We need to ingest all of that data, and all of that data is formatted slightly different. We're going to put it into a database, and then we have to determine the best track, and then we'll archive it and put it in an output. So this is what IBTrax looks like. So as you can see, there's a lot of different agencies, and essentially we're trying to get the best track from multiple agencies. So for example, in the North Atlantic, there's a few different agencies, and we're trying to find the best track across all of those. All right, so how are we using scientific Python to do this? So with those 22 different agencies, we're planning on using polars to ingest that data and clean it all up, make sure it's all in a nice format. We'll be using PsychoPG to ingest that data into a database. And then we don't really have any libraries yet for how we're going to determine the best track. So if anyone has any suggestions, I'd love to talk to you afterwards. But we're trying to find the statistical, best track, given the multiple outputs. And then we will output it into a shapefile, a NetCDF, and a CSV file. So we'll probably be using GeoPandas, polars, and NetCDF. But this product is still in the early phases. So if you're like, you shouldn't be using this library, come talk to me, and I would love to pick your brain. And then the next one I wanted to talk about is a new product. So I'll talk about the Event Footprint Catalog. And so the Event Footprint Catalog is the latest product to be developed, and it'll feature a detailed list of weather events characterized by their physical impact footprint. And 6 hazards have been targeted for identification. They are severe convective storms, which include tornado, hail, and severe wind, tropical cyclones, winter storms, and wildfires. But the first initial product is going to be focusing on severe convective hazards. And the purpose of this is really driven by the insurance and retail sectors. So the insurance sector is really interested primarily in detailed event footprints that they can use to help inform their catastrophe models. And the retail is really interested in primarily the documentation of events relative to their physical assets. So as I mentioned, this is very different than our modernization coding and products. This was really driven by the industry needs, and we really wanted to put this into Python because, again, scientists will be maintaining this, and Python is a fun language. So how will we be doing this? So we have those 3 footprints. So we want severe weather, winter weather, and tropical cyclones all to be displayed in a UI. But we kind of have to back out a little bit on the back end of how we're going to be doing that. So for severe weather, we will have 3 subhazards. We'll have tornado, hail, wind, and tropical cyclones will have wind or flooding or precipitation. So I wanted to dive into what those pipelines will look like. So essentially we have our input data. We want to automate or bulk download our data. And then depending if it's a new event or a past event, we'll either automate it or bulk download, temporarily save that data, calculate our footprint, and then store it as a shapefile or a GeoJSON. So this is what this looks like. So I have MRMS 24-hour hail swaths on the left-hand side, and on the right-hand side is what we're trying to produce. So the right-hand side has, it's in a shapefile, and it's grabbing hail that is an inch or greater. So it kind of cleans up the data a lot more, and it's a lot easier to use. The hail swath data is in, I believe, grid format, which is not very friendly to be playing with, where a shapefile, you can put that in ArcGIS and play around as needed. So this is essentially what we're trying to do with all of our different hazards. So I wanted to walk through how we're using scientific Python for specifically hail. So we have MRMS 24-hour hail swaths. We're going to be pulling it from an S3 bucket using Boto 3, reading it using Xarray, and then we're calculating the footprint using raster.io, and then outputting it to a shapefile or a GeoJSON using GeoPandas. And then hopefully putting it into the cloud or the nod. So again, if you have any suggestions on different packages that we could be using here, I would love to discuss more. But again, this really addresses the need that has been given to us from the insurance and the retail sectors. So I did want to address, we are working with our code in GitLab. So it is closed source. It's developed by, it's a small cross-agency team. We're pretty big. We're NOAA contractors, as well as NOAA and partners. And this is just due to security and infrastructure and proprietary constraints. But without any of these open source packages, and there are several that have not been listed here, we would not have been able to do what we're doing. We started this contract last year in April. We have another year and a half, and we have produced or started to prototype, I would say, 15 products. We've completed about 2 or 3 of those so far. So we would not have been able to do that without the open source community and packages. So thank you for everyone who's in here who has worked on these. We really appreciate that we would not be able to do what we're doing without that. So even though we're closed source code, all of our data is open since it is NOAA. So as I mentioned, we have output that's going to the nod, which is all cloud-based, and that can be found at this link. There is some GitHub repositories, so like billion-dollar disasters, that's going to be going into the public NCEI GitHub repositories. And then I have not touched really AI stuff, but we are looking into how we can use AI in our products. And NCEI and NOAA is looking at that as well, so that can be found at this GitHub. We're also creating Jupyter notebooks with all of our products, or a majority of our products, so that it could be easier to be spun up for people in those sectors. So NOAA is connecting the environmental intelligence and real-world challenges by co-developing solutions with our industry partners. So we have new collaborations with the insurance and reinsurance sector. We're helping to integrate hazard swaths and event metadata for exposure modeling. We are working with the retail sector to build services around accessible, fast, and actionable data sets. And we're also working with the architecture and engineering sector to customize climate data sets to inform design resilience. So The scientific impact of all of this is we're able to, build things a lot faster. We are able to have 20 plus years worth of data accessible in seconds using polars. We're able to help the sectors make operational decision making with real-time pipelines and support of disaster response. We're also are able to reproduce our methods that we're using. So pipelines are versioned and tested and validated via CI/CD. And then we're having all the shared outcomes on the nod, as well as the public GitHub and our website as well. So the Python agility and SciPy's ecosystem has really helped us to do this. So what we've learned is that the legacy pipeline can't really be scaled. So that's why we're using Python, the cloud, and validation to move forward. The scientific reproducibility is possible in production pipelines, and the community tools like Polars, NumPy, GeoPandas helped us to unlock modern climate science delivery. And SciPy's ecosystem really helps NOAA to move from archive to action. So with that, if there's any questions or any suggestions on packages, I would love to discuss more. So thank you.
All right, we have a good number of questions in the Slack. Let's start from Axel. Do you know if there's an API we can use, consume for this weather data due to this effort? Are you planning to expose it? Even if this is a paid resource, it might be tremendously useful.
Yeah, no, that's a good question. There's some products that we're working to have APIs with. I think the bigger haul is putting it into the cloud right now. I think eventually putting it into an API would be great, and we'll take notes of that. But I think that would be really helpful to have an API as well. So thank you.
From Charles, you said you're exclusively using either polars or pandas. Does that mean all projects use at least one of the two for something, or that each project uses either one or the other, i.e. no interoperability between the two?
Yeah, so there's some that are using only polars, there are some using only pandas, and then there are some that are using both interchangeably, or not interchangeably, but in conjunction with each other. It's kind of just dependent on what the product needs and what is kind of driving those requirements, as well as which one's faster with the data that we're using.
From Dan, what is the biggest source of friction in importing data from 22 agencies? Is it inconsistent formats, different authentication requirements, or something else? Yeah,
it's that the format's all slightly different. I think even from the same agencies, sometimes the headers are different, or the data's, so what was it? Character encoding, yeah, is different. So they're all different. So that is the hardest part with bringing all those different data sets in. And there's some data that's just missing. Like when I was working with billion-dollar disasters, there was a disaster number or start date that was just not there. So we had to kind of figure out where, different columns that we can figure out when those start dates were, and where those other data sets came from. So, yeah.
From Kevin, have you considered storing the output data sets in analysis-ready cloud-optimized formats like Parquet and ZAR, in addition to or instead of CSV and NetCDF?
That's a good question. I would love to. We do have some products that are outputting Parquet files in addition to CSV files. I think a lot of the new products are driven by the industry. So if they say that they want a CSV file, we give them a CSV file. But I think it is something that's really important for us to discuss if we can, put them in a ZAR file, because it's easier. And maybe we can create Jupyter notebooks for them to say, oh, this is how you pull the data down, to help build that community.
From Dan, is there cultural resistance to the IDL to Python conversion? And if so, how are you managing that?
I don't know if there is. Do you? I think everyone is kind of open to Python. I think there is some IDL lovers still, but I think having it in CI/CD and having user guides has been really helpful for them to get spun up with it.
Just this is sort of resource sharing, but Jay shared a website with a resource. I don't know if this is more for you, for everybody else, with some modern geospatial data formats. So there's a link shared in there.
Thank you.
All right, question from Axel. Are you open to collaborations to incorporate agentic AI to help these efforts?
Yeah, I know we are working with a lot of people with AI. So if whoever put that, I'd love to talk to you. We are trying to incorporate AI. There is, just some restrictions that we have with AI, so we have to specifically work with NOAA and NCEI's, I don't know. We have to work with them to get that up and running. But I would love to talk to you afterwards. Thank you.
Is there, going back to this like polars, pandas question, I guess, again, is there a cultural resistance to polars adoption? This person's a big fan, but it doesn't feel like the scientific ecosystem has integrated it much, perhaps due to the existing popularity of pandas. Yeah,
I think, because we've been developing, we started with pandas and then we were like, oh, polars is cool too. I think the helpful thing is we'll run through, okay, is it faster with polars? Is it faster with pandas? A few other things. Is it faster using SQL? And having that data to back up, okay, this is why we're choosing this, is really the driving force with that.
All right, and I guess, and we'll end with a banger, but given the cost and fragility of cloud in the current administration, are you interested in peer-to-peer data distribution mechanisms that can supplement or be complementary to the cloud systems?
That's a good question. I am a NOAA affiliate, so I don't know if I can really answer that directly. I know we are trying to at least be cloud ready so that the data is available and it's a little bit nicer to use than where it's at currently. But yeah, whoever said that, I would love to talk to you afterwards too, and I can kind of get you to the right people for that.
All right, unless there's any other questions in the room, I think that's it. So let's go ahead and thank our speaker again.
Thank you.